Introduction. This project compares two CPU scheduling algorithms, FCFS and SGF, using C on a Linux platforms. It aims to evaluate performance based on average waiting time, turnaround time, and fairness. Simulations with multiple processes and Gantt charts helps visualize schedulers' behaviors. The project provides hands-on experience and deeper understanding of how schedulers affects system performance.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Mimi Nur Mazrin binti Muhammad Som. My metric number is AN220006. For the project description, this project simulates and compares two key CPU scheduling algorithm. The first one is first come first serve FCFS. The second one is shortest job first, which is SJF. Both algorithms were implemented using C language on Linux via WSL. For the assumptions, all processes arrive at time 0 and each process has a unique ID and defined CPU burst time. So for the performance metrics, the first one is waiting time, the second one is turnaround time, the third one is average waiting and turnaround time. So for the tools, our group used Gantt chart to visualize CPU scheduling sequences. And this project helps analyzing efficiency, fairness, and the real-world impact of scheduling algorithm in OS design.
First come first serve is the simplest CPU scheduling method where processes are executed in the order they arrive. It is not preemptive, meaning each process runs until it finishes. While easy to implement and fair by arrival time, FCFS can cause long waiting times if short tasks wait behind the longer one, a phenomenon known as the combo effect. The advantages of FCFS, first one is easy to implement, easy to understand and coding. The second one is pay by arrival time. Processes are handled in the order they arrive. The third one is no starvation. Every process will eventually get CPU time. Disadvantages of FDFS. First one is the high average waiting time. Short processes may wait behind the long one. Second one is non-preemptive. Once a process starts, it runs to the completion, reducing flexibility. The third one is the combo effect. A long process can delay all others, lowering overall efficiencies. This C program simulates FCFS scheduling by taking process IDs and burst times, then calculates each process waiting time and turnaround times. It displays the result in a table and computes the average waiting and turnaround times. Come to the result and analysis. We conducted three FCFS scheduling tasks using 4, 7, and 10 processes respectively. This is the actual test result summary. For 4 processes, the average turnaround time is 12.75, average waiting time is 7.25. For 7 processes, average turnaround time is 21.714285. Average waiting time is 16.714285. For 10 processes, average turnaround time is 50.5. The average waiting time is 41.099998. This is the Gantt chart for different processes. Since all of the processes are arriving on the same time, which is time 0, so all the process executes following the number of sequence. For example, 4 processes are executed from P1 to P2 to P3 and then finally P4. Same for 7 processes and 10 processes. Comparison with theoretical analysis. For number of processes, for the AWP is 7.25 in actual and is same in the calculation. ATT is 12.75 in actual Calculation also the same. For 7 processors, AWT is 16.711425. The calculation is 16.71428571. The ATT is 21.714285. The calculation is 21.71142857 For 10 processors, the AWT is 41.099998. The calculation is 41.1. The ATT is 50.5. The calculation is 50.5 also. So we found that uh, the result from the actual test and the calculation is almost the same. Maybe only a big difference from the decimal part.
Hi, my name is Nur Aldira. Today I will present about second algorithm which is shortest job first (SJF). For the algorithm description, shortest job first scheduling is a non-preemptive CPU scheduling algorithm where the process with the shortest burst time is selected for execution first. This approach aims to reduce the average waiting time by giving priority to shorter tasks, which can lead to be more efficient CPU utilization compared to first come first serve. In SJF, all processes are assumed to arrive at the same time, and the schedulers select the job with the smallest execution time to run next. Once the process begins execution, it runs until completion without interruption. While SJF can significantly improve performance, it requires prior knowledge of each process burst time and may lead to starvation for longer process if short one keep arriving. Advantage and disadvantage of SJF. First is the advantage. It reduces the average waiting time. Second is give the lowest average waiting time for a specific set of process. Third is optimal regarding average turnaround time. For disadvantage, first is cannot be implemented at the level of short-term CPU scheduling. And next is total execution time of a job must be known before execution. And lastly, there is no way to know the length of the next CPU burst. This is the program code for SJF. For the SJF scheduling process is implemented by first taking a user input for the number of processes and the burst time. The program then sort the process in ascending order based on the burst time. It calculates the waiting time for each process by determining when it will start based on the completion of the previous process. The turnaround time is then computed by adding the burst time to the waiting time of each process. The program outputs the waiting and turnaround time for all processes along with the average, effectively demonstrating how SJF scheduling prioritizes shorter tasks to optimize overall performance. This is the result for number of process 4. There is a 4 process. For the P1, we enter the burst time is 5, P2 3, P3 8, and P4 is 6. And the results show that priority 1 is P2 with the burst time 3, waiting time 0, and turnaround time 3. And second priority is P2 with the burst time 5, waiting time 3, turnaround time 8. And third priority P4 with the burst time 6, waiting time 8, and turnaround time 14. And lastly is the P3 with the burst time 8, waiting time 14, and turnaround time 22. So for the whole process, average waiting time is 6.25000, and for the average turnaround time is 11.75000. The second result we get is for the number of process 7. There is 7 process. We enter P1 as 5, P2 as 8, P3 as 2, P4 as 5, P5 10, P6 4, P7 1. And for the result, we got the first priority P7 with the burst time 1, waiting time 0, turnaround time 1. For the second priority is P3 with the burst time 2, waiting time 1, turnaround time 3. And for the third priority is P6 with the burst time 4, waiting time 3, and turnaround time 7. And for the fourth priority is P4 with the burst time 5, waiting time 7, and turnaround time is 12. And for the fifth priority is P1 with the burst time same with the P4, which is 5, waiting time 12, and turnaround time 17. And second last is P2 with the burst time 8, waiting time 17, and turnaround time 25. And lastly is P5 with burst time 10, waiting time 25, and turnaround time 35. And for the average waiting time for the whole process is 9.285714, and for the average turnaround time is 14.285714. This is the result we get from the theoretical. The process execute in order of P2, P1, P4, and P3. First, the P2 will execute start from 0 to 3. Next is P1 from 3 to 8 with amount of time is 5. And next is P4 from 8 to 14 with amount of time is 6. And next is P3 with amount of time is 8. This is the calculation for the waiting time. Waiting time is start time minus the arrival time, assume as 0 because we calculate based on the Gantt chart. For the P2 is start with 0 minus 0, we have 0. And for the P1, start time is 3 minus 0, we have 3. P4 8 minus 0 equal to 8, and P3 is 14 minus 0, we have 14. For the average waiting time, we have 0 plus 3 plus 8 and plus 14, and divided by 4 we have 6.25. And next is the turnaround time. Turnaround time is waiting time plus burst time. We have P2 is 3, P1 8, P4 14, and P3 is 22. For the average turnaround time, 3 plus 8 plus 14 plus 22 divided by 4, we have 11.75. Next is the result for number of process 7. We have process execute in order P7. Next is P3, P6, P4, P1, P2, and P5. For the Gantt chart, it starts with P7 because it has the lowest burst time, which is 1. And next is P3 with burst time 2. Next is P6 with the burst time 4. And P4 has 5 burst time. And next is P1, same as P4 with 5 burst time. And next is the P2 with burst time 8, and lastly P5 with 10 burst time. This is the calculation for the waiting time, which is start time minus the arrival time, assume as 0 because we refer to the Gantt chart where the start time for the P7 is 0, which is next is the P3 and equal to 1. P6 we calculate have 3, P4 7, P1 12, P2 17, P5 25. And for the average waiting time, we have 9.8571426. And for the turnaround time, we have waiting time plus burst time. P7 we have 1, P3 3, P6 7, P4 11, 12, P1 17, P2 25, and lastly P5 we have 35, and for the average turnaround time for this divided by 7, we have 14.28571429. This is the result and the calculation we have from the lab. For the number process 4, we have average waiting time 6.25, and from the calculation we get 6.25, and for the theory average turnaround time we have 11.75000, and from the calculation we get the same answer, which is 11.75. And for the number of process 7, from the theory we have average waiting time 9.285714, and from the calculation we get 9.28571426, and from the average turnaround time from the theory we get 14.285714, and from the calculation we get the same answer, which 14.28571429.
From the analysis result, SGF performed better than FCFS in all test cases. As the number of processes increased, SGF showed significantly lower waiting and turnaround times. For 10 processes, FCFS waiting time is 41.010 and turnaround time 0.50. SGF waiting time to 8.40, turnaround 37.80. SGF is more efficient for handling multiple processes, especially when burst times are not.
Conclusion: this project compared FCFS and SJF scheduling algorithms using C in a Linux environment. Results shows that SJF performed better, reducing average waiting and turnaround time significantly. FCFS is simple but less efficient due to the convoy effects, while SJF improved performance by prioritizing shortest tasks. The project highlights the importance of choosing the right scheduling method and provided practical experience in system programming and analysis.